Hi guys, how are you guys doing today? This is Mr. Mark and we are going to be looking at our science experiment. But I must say, I hope you guys are doing well. I hope you guys are safe. I hope you guys are constantly washing your hands. Keeping your hands clean is very, very important at this moment in time. So please guys, I'm imploring you, please keep your hands clean. So constantly wash your hands on a regular basis. Now, we are going to be looking at our science experiment, and for this science experiment, we are going to be looking at the refraction of light. Now, students, before any experiment, we should always remember to take a look at our scientific method, which constitutes of a couple of things. One, observing or observe and ask question. Two, form a hypothesis. Three, plan an investigation. Four, conduct the investigation. And number five, we draw a conclusion and communicate our results. So always remember to look at your scientific method. So you observe, you look what is happening, you see what is happening, and what is it you want to learn about. Then you form a hypothesis or hypothesis, right? It's a possible answer to a question that you might want to ask, something that you want to test, something that you want to find out. And as a result, you would plan your investigation. Planning your investigation to see what are the possible answers to your question. Then you go now and you conduct your investigation. And while conducting your investigation, you observe exactly what is happening. You do your investigation probably 2 or 3 times to ensure that you have conclusive results. And from there, you move on to your conclusion. What is your conclusion? What is it you conclude? What answers you come to? And then finally, after documenting your answers, your conclusion, you communicate that conclusion via data. Now, students, on this slide you see where we have the experiment overview. This gives you a synopsis of what your experiment ought to look like. Now, this says, this light refraction experiment takes only a few minutes to set up. You'll draw 2 arrows on a sticky note, stick it on the wall, then fill a clear water bottle with water. As you move the water bottle in front of the arrows will appear to change the direction they are pointing. This is because of the refraction that occurs when the light passes through materials like water and plastic. So please look at it carefully, and guys, you need to follow the steps precisely and carefully. Now guys, there's a couple of things that you're going to need to get this experiment sorted. As you can see on the PowerPoint, you're going to need a sticky note. Get yourself a marker. A Sharpie, something that you can write with, and ensure that your sticky note is clear, easily seen, preferably a light color, probably yellow or something. Transparent water bottle. And fill that water bottle with water, and that's what we are going to use. Now we're looking at step one as we go through the steps. First, we draw two arrows on a sticky note. Make sure, absolutely make sure that each arrow point in a different direction. And now you stick the note to a blank wall. Find a blank wall somewhere and stick it. If you don't have a blank wall, see if you can get some white paper and put it on the wall and stick it on the white paper and ensure that your bottle is actually very, very close or in line with your white paper. Now for step two, guys, you fill the water bottle with water, but guess what? After filling the water bottle, you want to close it, because when you're moving the water bottle, you do not want the water to be spilling all over the place. So ensure that the water bottle is closed tight, and as a result, you will not spill the water wherever you're using. Now for the third and final step, you will notice the alternating arrows on the note point to the left and the right. Move the water bottle filled with water in front of the sticky note. As the bottle moves in front of the sticky note, something amazing will happen. The arrows appear to change direction. The top arrow, which points to the left, appears to point to the right, and the bottom arrow, which points to the right, appears to point to the left, which I find really amazing. Now move the bottle back to see the arrows return to their original direction. That is amazing. Now finally, guys, you should be done with the experiment. Now you are going to be looking at the last slide, which speaks to the science behind the entire thing, why the arrows would appear to go one direction when originally they are going to another direction. Now you're going to read the slide that speaks to the science behind it, after which you're going to complete the form that you were issued via Class Dojo, your lab form, and ensure that you put in all the details, guys. Please ensure that you put in all the details. Remember your question, your hypotheses, your results, and your conclusion.